Hello, everyone, and welcome to another book club session. Today, we are delighted to welcome Diana Montalion. In today's session, we will learn about how systems thinking can help us lead up teams, design software, work better in organizations, and also deal with social challenges. Diana is a systems architect. She's also a Mentrix founder and author of the book Learning Systems Thinking that was released July last year, actually. Diana, it's a pleasure to have you here. Before we start, I would like to remind the audience that you can address questions through the YouTube chat. And now is your time. It's all yours. Thank you, Diana.
Thank you, Ivan. So we're gonna talk a bit about what you'd find, practice, and explore if you read the book. But let's begin with the whole entire point of doing so. So I'll tell you why I wrote it, because this is often a question that comes up. So this is me. I began as a back-end engineer and then played engineering roles across bigger and smaller teams. And our challenge was always trying to translate this constant emerging complexity in software systems. And in my case, because I work in predominantly digital systems, the amount of complexity was originally very small and now is incredibly big, into a particular way of thinking. And I use the phrase linear thinking to describe what's happening inside the room. This is somewhat exact and somewhat poetic license, but the idea is that we are able to translate the challenges that we face into if you do A, you'll get B. We tend to envision system changes, software system changes like this. We tend to envision how we can manage our own time and activity in this way. And for me, the challenge was that it wasn't working. And I worked on a number of very big digital transformations. So I was architecting, moving from one type of system to another type of system, and then watched the entire effort and initiative hit the same iceberg and sink again and again and again. And so we're going to talk a little bit about what that iceberg is. And I'm sharing with you the disappointment that I experienced, that you might experience as well, which is that I really thought that I would be able to solve challenges with Kafka streams and Kubernetes clusters and increasing my skill set so that I could work in Go instead of PHP. But the reality is, it is the way we think and communicate. It's the rules we have about what thinking is and what thinking isn't that are most often the reasons that we as individuals and as teams and as organizations fail to be able to generate modern systems that require our ability to think in systems. And so, instead of writing a book about Kubernetes and Kafka, I wrote a book about systems thinking. And systems thinking, the way that I use it, actually means a number of different things. You could say pattern thinking or nonlinear thinking, or even I would say systems architectural thinking, systemic reasoning. There's a lot of different ways that we talk about how we think when there's no one right answer. When we can't turn around to those people inside the box and describe a solution, a single way to get from A to B. What type of thinking skills do we use in that situation? And what type of blockers do we find when we try and do it? So that's the highlight that we're going to talk about and answer some questions on, and then, of course, encourage you to dive deeper by reading the book. And so When we think about thinking, we generally think of linear thinking, especially in software development. We want to be rational. Decisions are generally made from the top down, procedural and predictable. So we want to be able to do things in a patterned kind of way. And when we push something to production, we want it to do what we designed it to do, and concerned with control. So most of the thinking processes that we both use to build software and we use on the process of building software would fit into this model. We think of how do we control people's time, energy, and attention? How do we make decisions that trickle down to implementers? And this is part of what we could think of as reductionism. So object-oriented programming, for example, is a form of reductionism where what we do is we break down complexity into parts that we can build and understand and focus on. And this is actually an important process for us to do. I am not arguing that linear thinking and reductionism are bad and we should throw them away. That is not the case, because we need it in order to be able to deliver and develop technology solutions and also to think with other people. The challenge is, though, that as relational complexity increases in a system, right? If you're working on one piece of software that has one primary capability and does not interact with any other API or service or anything else, then these types of processes are going to be more effective, or at the very least, they're always more efficient. But as most of us have all the time now, working in systems where software parts are talking to other software parts, and where the engineering team and the product team and the business team and design and commercial and ads and all of these people, parts of an organization, are making decisions that inherently design what the system will do and how it will do it. These types of reductionistic siloing approaches, they begin to add up to problems that we can't solve, right? The system becomes stuck. And I have an organization called Mago, that's fiction, that you'll see in the book, where I describe the challenges that this organization is experiencing. And the key in this organization is it will look like most software systems you've seen, where things get added on and duct tape with rickety bridges between one piece of digital software, for example, that might publish to the web, and then there's something publishing to apps, and then it content or information goes to social media, and there's no real systems design between them as much as there are scripts that move them around. And what happens is, because it gets generated by a system that has a worldview of thinking, this is the print team, this is the digital team, this is the app team, this is the video team, this is the social media team. But while this might be the case for the types of software we're using, the reality is there's the data object, the data flow at the bottom of this system is something flowing everywhere, is the ability to create information and share it across multiple contexts. And so this is what I mean, among the things I mean by relational complexity, which is that as a system, as we move towards microservices and event-driven, as we're using messages and clusters, what we're actually doing is designing relationships in a system. And so when we're doing systems thinking, we are trying to understand how those relationships produce effect. Meaning, If we're looking at one particular piece of software and we're finding a place where there's a bug in the code, that's great. That's a great day. I like those days. We're finding a bug in the code. Then we're usually going to draw more on a linear process of trying to figure out why this particular loop isn't giving us what it is that we think it will. But usually what we're looking for nowadays is something in eventual consistency, or something in the way that different parts of the system interact with each other asynchronously. So for example, maybe one piece of software hits the API for another piece of software and gets an answer. But elsewhere in the system, so let's say if this is an e-commerce system, maybe when an order is placed, the relationship between the part of the system that tracks inventory and the part of the system that provides a shopping cart has a really good relationship. But when the payment processor gets involved, the payment processor doesn't hit the same API, doesn't use the same pathways. Instead, it goes around the logic layer and gets data right out of, say, the Oracle database or whatever it is that's in the back. So now you have a relationship where the system is communicating in one way when people are shopping, but another way when a payment is processing. And this relationship is going to produce some incongruity in the outcome. And so also, this is a positive thing. Relationships produce effect is what we want when we have a services environment. So for example, if I have two services that are very essential to what this software system does, ideally, the outcome that I get is something that neither of those two services can do alone. In the example of the shopping cart, the situation, the service that does the shopping cart and the service that tracks the inventory, neither of them could let a user buy a pair of shoes or whatever it is, that a book, whatever it is that they're buying. It is only because they are in relationship to each other that we get that outcome. And so when we are thinking in systems, it's not that we ignore linear processes or parts. It's not that we don't do analysis, and it's not that we don't set good boundaries. It's that we also think about how the parts are connected and what are the patterns that govern the way that people and technology interrelate. Does a change in the system improve the quality of the system overall? So for example, when we think about wholeness or we think about synthesis, when we think about synthesis, what we're thinking about is that this system has a purpose. So for example, FedEx as an organization, fast package delivery. That's what they do. That's what they're known for. So if I'm making a recommendation for Kubernetes or Kafka or for event-based interactions or whatever the technical recommendation is, or maybe my product colleague is making a recommendation for some improvement in the user experience and the flow through which someone buys what they're buying, that together we're trying to make sure that we understand, will this improve fast package delivery? Will these things synthesize to make a better system? Or are we actually improving one part, but having a potentially negative impact on other parts? And so we think about what is called emergence, which means what I had said earlier, which is that when two or more parts are working together, that they produce something valuable that neither of them can produce alone. And the shift to systems thinking for software professionals is you're actually designing for that. You're designing relationships, you're designing patterns, you're designing structures of communication in the software and in the people making decisions that will give you these kinds of benefits. And that's why I say that linear thinking, it doesn't scale, because the thing about reductionism is you can break complexity into parts in order to understand them. That works great, but it doesn't work the other way around. Understanding a part does not help you understand the system as a whole and the places where relationships are having impact on the system. And so one of my favorite ways of describing this is from Donella Meadows' Thinking in Systems. She says that you think that because you understand one, you must understand two, because one and one make two, but you forget that you must also understand and. And that is the challenge that I personally experienced as my opportunity to solve wicked problems, as my opportunity to work with organizations across the system of software in a way that really was about, digital transformation. But what we mean by that is simply the movement from a pipeline process to a context dependent process. In other words, we could understand different context. This began, for a lot of us, it began when we thought about different devices, that somebody on a desktop, not only do they need a different experience in their browser, but they're often looking for different things than we do when we're on our phone. And so that has now expanded exponentially. What do we ask Alexa for? What do we pick up our phone for? What does our car tell us, or our smart fridge tell us? What does a particular person who is experiencing fast package delivery in a rural area, how is that going to be different for them than someone in New York or Boston or Berlin? And so the ability to design for the and also to design for different contexts has become so important. And yet organizations really, really struggle with the ability to do so. And the thing is that what I wish then the book dived into are some pretty easy answers to what to do about that. And the challenge is that in systems, the smallest patterns will scale to be the biggest challenges. And that the challenge is that it is our own thinking. It is the patterns in our own thinking that are the most core to systems thinking, because the what you think and what you talk about is what you're going to push to production. So if your mind is very conditioned to think in linear, transactional types of architectures, and now you're trying to design something that's asynchronous, you're going to have to change your entire thinking about time. You're going to need to worry about different things, because different things are going to bring down production than what you're used to. Caching is not going to adding more caching probably won't fix your problem. And what will? And so the ability to then, this is what I borrowed Conway's law to make Diana's law, that people who design systems will produce copies of their thinking and communication patterns. And so part of the book is focusing on metacognition, how to work with your own thinking patterns, logical fallacies and cognitive biases, which are basically bugs in our own thinking. And if you start to pay attention to them, you will discover how many there are, and also how difficult it is for you to describe why you're making a recommendation. Why will Kubernetes help fast package delivery? We're not as skilled at doing that as we might think that we are. We're not as reasonable and rational as we might think we are. And so one of the things we do when we're practicing systems thinking is to practice with our own mind, but also we practice with how we engage with other people, because there's ways we engage with other people that encourage systems thinking, and there are ways we engage with other people that will that will turn it off, that will immediately shut down any ability to understand a problem from multiple perspectives, or understand a problem in a way that allows you to synthesize. And we have a lot of those habits, a lot of those communication habits that are arise from a more linear type of environment. And so we are making changes not just in the way we think, but in how we share and structure our ideas. And we also are going to run into, consistently run into a few blockers. So one that I've just alluded to is opinion giving. So we are very big on sharing opinion. And usually, for example, I know a number of organizations I've been part of, like request for comments. If there's an idea that we have about a change that we might make, we ask for comments. I personally don't use this approach anymore, because what I get is people's opinion. That looks like a graph, and graphs don't scale. And the thing is, I can't do anything with that, because I actually don't know what convinced them that graphs don't scale. In what context have they experienced it? How, in my architecture, am I specifically doing something that is worrisome from a scalability point of view? And so the pattern of giving an opinion rather than drawing a map, how did I arrive at this conclusion? And the reasons that justify our opinions are the substance with which we build systems thinking. It's not about whether we're right or wrong, because when we're thinking in systems, usually there's not one right answer. We could probably do 5, 10, 50, a million different things in order to improve the system, or to change the way that we're working. But we're trying to come up with the best possible one under the circumstances. And in order to do that, it requires us to draw a map to, why do we think this is the best possible solution? Or why do we think this path is a dead end? And in the reasons that justify our conclusions, we will find the real knowledge and information, the thing that really is going to help us. And this is why top-down communication often stymies systems thinking, because do this because I said so doesn't help us design whatever it is that is so meaningful we're being asked to focus on it. Understanding why something improves fast package delivery from the business perspective and the product perspective helps us then design in the software something that will really impact fast package delivery. That'll be effective and not just efficient. So another challenge is represented by the beer game, which I won't describe the whole thing to you, but it's wonderful to look up and learn about the history of the beer game. But what we know from the beer game, from 50 years of systems science, is that as relational complexity increases between teams of people, that what we do is we blame. We blame the other team. We blame the other team. We blame product. We blame leadership. We blame the legacy system or the monolith, or we blame trying to do microservices. We blame. Outside of tech, that's what people do. It's not a tech. It's not just us. It's everybody. We blame. And the thing is that we are not just blaming, but we're blaming the wrong thing. And this is called counterintuitiveness. So what happens is that we blame something, and that would actually be fine if that meant we knew immediately what was the root cause of a problem, what was causing a problem. But unfortunately, the vast majority of time, individually, as a team, as an organization, we will jump to a conclusion about what to blame, and it'll be the wrong thing. And then we will act in a way that makes it worse. And so the one that might be the most familiar for us, as an example of counterintuitiveness, is that adding manpower to a late software project makes it later. You can understand how people might blame the difficulty with estimating, the wanting something that will take a year to build to be done in 3 months. Therefore, if I want it to be done in 3 months, all I have to do is just add more engineers and then it can get done. But a little bit of experience in the industry shows us that is not how it works. It makes it worse. There are a lot of other very valuable things that you can do if you think about how do we get ourselves into this situation in the first place? And so the just simply recognizing that you're going to need to make some space to think about, what are we blaming? What are we doing as a result of what we're blaming? And is it justified? Or in fact, is there somewhere better to look? And so the last example that I'm going to give is the iceberg model. And this is a common model that's used in a system. But what it basically reminds us is that everything that happens that's visible. So for example, if there's a bug in production, the system is designed to give exactly the outcomes that it gives. The call is always coming from inside the house. That rather than blaming external circumstances, what we're really looking for is, what are the patterns and structures and core beliefs? How is the way that we think and the way that then we structure our thinking into processes, into procedures, how is that contributing to the things that we're seeing in production? And can we change those so that we get a different result? And so there's a lot more to this about how you think about these types of things. And again, just like everything in systems, there will never be one root cause or one iceberg model. You're just using this as a way to help yourself identify some other options besides the ones that come up in blame, some other things that you can do that will have a big impact. And those are called leverage points. And leverage points in a system is actually the point of system thinking. When in a leverage point, what you're trying to do when you find a leverage point is a place within the system where a small shift in one thing can produce big changes in everything. So this is very different than patching and hacking. This is where you're actually trying to shift a pattern or a structure or a core way of thinking or operating that will in fact get you more of what you need. And so there's a lot about the ability to, when you find leverage points, how to make recommendations that actually can be acted on or will be acted on. And I guarantee it's going to be different than what you might currently be doing or thinking about how we describe these things. And so the book, more than anything, really just encourages you to practice, because I am using a very limited understanding, a very limited view of systems thinking as it applies to our lived experience. But of course, there are many other ways of approaching things than I have. There are many other circumstances that you might be in that I'm not familiar with. And so really, systems thinking is something that is emerging in the industry as a whole. And each one of us is part of contributing to that knowledge, to that experience, to helping us to understand how we avoid hitting the iceberg and how we are effective as complexity increases. So I'd love to hear if you have any questions.
So Diana, I think we have just one question for now. I will start with mine. What inspired you to write the book?
Yeah, so it was exactly the things, pain. Pain inspired me, in that, like I was saying, that as a software engineer and as a systems architect, and also just as a human being, trying to do things that matter, trying to sincerely give organizations and other teams and my teammates what would really, and users, and like design things that really mattered and were helpful, and discovering how difficult that is. It's incredibly difficult. And there are lots of reasons why it's difficult. And there are lots of other really good books that are helpful for different ways of thinking about this. But there's a lot of different ways. There's like psychological safety, and also more specific architecture, like how you model an architecture, architecture decision records, and the Andrew Harmer Law's book about how we how we do decision making differently. There's lots of ways, but because I'm a wicked systems geek, like that's my thing. So this is where I focused, which is how do we shift our thinking so that we can be effective.
Okay, we have 2 more questions. How do you balance systems thinking with the need for quick decisions in high pressure environments?
Yeah, the perennial question, right? Like, so I'm sorry ahead of time in that the answer is almost always, it depends. Because that it does. It depends on context and why people are doing the way why they're doing what they're doing. That said, systems thinking is about the ability to articulate what it depends on, right? So yes, it depends, but in this circumstance, how would you balance those things? And so for me, the primary question there is, I put in air quotes, need. What is the need? Is it really a need? Like, will puppies die if we do not make a quick decision in this high pressure environment? Like, do we really need to make a decision? And if we do, like you would in an emergency room. So for example, I use the example about having a heart attack, right? That if someone is having a heart attack, this is not a time for a lot of discourse about what to do, right? In this case, you do it. You make decisions and you do it, and it depends on expertise, right? And so I would say that is a need to make a quick decision. And in that case, one would expect the surgeon to already very much understand the human system well enough to act. Right? That there are certain patterns that say this is a heart attack. We do not have to discern that that's what's happening. They understand how that impacts the lungs and the other parts of the system, and they can take action because they know exactly what to do. Other times, the need is more about control, wanting to maintain control. And when you're being pressured to make quick decisions in order to reinforce control, you really aren't doing systems thinking in those moments. And so often, for a while, you're often doing systems thinking so that you're better at giving an answer in those moments. So you, like the heart surgeon, are understanding the system, but the long-term goal is to ease up the pressure to make quick decisions and encourage the pressure to make impactful decisions. That this decision is going to change things the way that we need them to be changed. And so that takes time.
Right. We have 3 more questions. Next one is from Anul. What techniques do you recommend for engineers to make their mental model explicit?
Yeah, well, I have to say, the fact that you're asking me about doing that makes me so happy, because I often need to explain why it would even matter to do so against people who don't want to do so. So like the fact that there's a yes, I'd like to make them explicit. And so there are what I would say is I have a whole mishmash of modeling techniques. I borrow from domain-driven design. I do event storming. I borrow from, I still actually like UML. It's a little bit old school. I borrow from business process modeling. I borrow even from TOGAF, although I don't fit architecture into an enterprise frame generally. I just open a Miro board and start making boxes, lines, and things, sometimes just free form. So what I would say is that it's kind of like food, in that what I really like best, what I'd choose on a Friday night, might not be what you would choose on a Friday night. And that's okay. The thing that matters is that you are establishing the pattern in yourself and with other people to make the mental models explicit. And what'll happen is you'll find maybe you use C4, and in some ways it works great for you, but there's things you can't express that way. And so you'll add another one that you'll link to. So here's C4, and here is a schema model, right? So you might mix and match and interrelate them until you find that, yes, I have expressed this mental model. And what works with one team will not necessarily work with another team. So get a few that work for you. Go to workshops, try them out, take courses, see what you like, and then experiment in your situation and see which ones really do enable better understanding of each other. And it really will depend. I cannot tell you how much it varies from team to team and organization to organization.
All right. So we go for the next one. What are the common misinterpretations of systems thinking in the tech industry?
That systems thinking is Kubernetes. That if I know how to implement Kubernetes, I am a systems thinker. And now you are actually often doing this. Like I say this, I'm a little bit, this is my also sarcastic joke of describing it. Also, so the idea that systems thinking applies to infrastructure implementation into tools. It is the design of topics in a Kafka stream. But at that point, we are actually more in engineering thinking than systems design. And that's great, because thinking in systems without ever implementing why would we be doing this, right? We actually do want to translate them, and the tools themselves will also inform our thinking. So if only the tech did everything I want it to do, then I could think in systems and think, hey, if we make this part more performant, we will really unlock a lot of the blockers that we have. Except that the tool that I would be tweaking cannot be made more performant. It is already exactly as much as it can do. So the technology tools have constraints. Also, people have constraints. You might not have the expertise in an organization to do something the organization wants to do. So we're misinterpreting systems thinking when we think that it is the measure of the structured outcome, as opposed to the ability to adapt as we learn. So we implement something, and then we learn from it, and then we change it, and that we adapt to it. So if systems thinking is a deliverable, then that's usually not systems thinking.
Okay, the next one. What patterns have you observed in organizations that successfully adopt a systems thinking approach to software?
So, yeah. So I have a low level and a higher level answer to this. On a low level, that my previous team, for example, for the most part, we were 5 people with different perspectives and different ways of thinking who could get together in a room and solve hard problems together pretty well, pretty effectively. And also we had a lot of fun doing it. They enjoyed each other's thinking, each other's company. The problems themselves were hard, but our ability to reason and rationalize about them together, even though there was a lot of uncertainty. It was a greenfield project. There were many decisions we had to make, just leap of faith decisions. And so at the lowest level, it is a reduction in friction, meaning that the patterns in organizations that successfully adopt systems thinking, the way you tend to know it is that you're able to not get stuck in blame and counterintuitiveness. You're able to listen to each other's ideas but still come out with something to try, right? And at the organization level, one is that it's a good culture. Like, there's a swear word that I use that I won't use, but that I'll soften it to: don't be a jerk. People aren't jerks to each other, right? That they're not establishing power and dominance. They're legitimately trying to find effective ways to structure knowledge sharing so they can solve a problem. So in an organization that's successful at systems thinking, they will usually have the exact same systemic problems other organizations have. It's still hard. There's still too much caching. It's still hard to figure out how to add new features. They're still trying to orchestrate, and they still struggle with CI/CD. Like, it's with the same things. But there is a lot of activity that is signal, that really understands these problems and is engaging with the problems. In an organization that isn't successful at adopting systems thinking, there's a lot of noise. There's a lot of bike shedding. There's a lot of blaming. There's a lot of going in circles, and there's very little experimentation. And while that doesn't say what the patterns that got them there, it does say the patterns that show you whether they're getting there or not.
Okay, well, the next one, how to train myself to keep system thinking.
So this is not a popular answer, but it is. I wanted to pause for a minute to see if another answer came to mind, but it doesn't. Writing every day, especially in the morning, and I want to be like, I'm so sorry. But the first thing is to become aware of your own thinking patterns. And then the second thing is to become aware of what you can contribute different from the noise, from the pattern, from reacting, from blame. And for me, I don't know what I think if I don't spend some time thinking every day. And I don't mean time to think where you write a particular racy template. I mean just time where you set a timer for 20 minutes and just write whatever you're thinking about, just engaging with your own thinking. And that once that pattern is established, then you can try approaches, right? You can try modeling approaches, you can try techniques, you can improve this type of thinking, fast versus slow thinking. But until you have a pattern of just having conversations with yourself about your thinking, you won't get very far. And so basically, it's sad to say, but one of the reasons most of us don't practice systems thinking is we're knowledge workers who have no time to think. We have like no time in our day to think. So making time to think is critical.
Great advice. Okay, the next one, as an engineering manager, what do you think it would be a good way to introduce systems thinking to the team or engineers in a world already filled with so many things to learn?
And it is like, so first, I really want to empathize with the last part of that question, right? Like in an interview once, someone said, oh, Diana, I'm so busy. My cognitive load is so high. And it sounds like you're asking me to think about everything. Now you want me to think about everything. Like, I feel you. And it absolutely is not what I'm saying. What I'm saying is we're trying to discern what matters to think about and not exhaust ourselves thinking about all the other things. But how do you get there, right? So that exhaustion of, and there's so much to learn, there's so much to know. When I look at the chart that I used to understand the skill set of engineers I hired 20 years ago, and then I look at the chart to assess, to think about the skills of engineers I would hire today, it makes me laugh. I would spit coffee out my nose if I looked at it while I was sipping coffee, because it's ridiculous. It's just ridiculous, right? So we really are under that pressure, and we have to be faster, more productive, and more efficient while we're also. When I give a talk, I ask the room often, so it's going to be like 2,000 people in the room, and I say, how many of you are working on the same tech stack you worked on 10 years ago, 5 years ago, 1 year ago? Generally speaking, 50% of the people in the room are not working on the same tech stack they worked on a year or two ago. That's how fast, even if you have the skills, you need new ones. So that aspect I want to really call out can make even the idea of systems thinking overwhelming, right? Because you have to get there. So what I would say as an engineering manager, and I'm doing this right now, and I am so thrilled, I can't even tell you. I feel like I'm watching the best parade ever, is that the engineering managers got together and we did some event storming on the system. Like, we did event storming on the system as a whole. What does this entire software system on all the different teams, what does it look like? And then a couple other architecture, decision record creation, a couple other of these skills. And then the engineering managers went back to their teams and they used whatever it was that would be helpful. Like if they're making a decision, they'd use the advice process, which is in the Facilitating Software Architecture book. If they were building a new service, they'd do some event storming on the current system, and then we'd add some other exercises from there. And so I sat through a presentation of a model of the caching system, which is incredibly complex, that one of the engineering managers worked with other people and just generated. Like, I'm seeing so much good systems thinking come out of people just because they were given the opportunity to do some. Like, people want to really share their ideas and their thinking. And I'm learning so much from what their teams are doing without doing much of it myself. So my experience is if you plant the seed of starting to do some modeling, starting to give people just one tool that helps them think about the bigger picture of what they're engineering, that sometimes doesn't work. But sometimes it actually gives people permission to start giving you models, start giving you architectural decision records, start giving you things, and then they do it with other teams who do it back to them. So it really is just trying to plant the right seed that will grow in the soil where you are.
All right, so I'm gonna make the last question for this session. If readers take away just one insight from your book, what should it be?
That we are knowledge workers in a world that increasingly reinforces what is called, one way of calling it is Taylorism, reductionism, industrialization, the idea that we are cogs in a factory model of delivering code. And AI brings up this question and concern for people a lot. But that at its heart, what systems thinking is really just reinforcing and reaffirming that our ability to create knowledge, to come up with something new from the same old ingredients, and be able to shift how we do things in a way that matters to the world, we have so much power. Like, the world is incredibly impacted by the software we've built in the last 10 years. It's shocking, really, how much in the world is impacted by software. Everybody walks around with software in their pocket. And that at the heart of it is our ability to actually engage with why that software matters, what is the impact of it, and not strictly on better JavaScript. It's not, we want to be great at JavaScript, but also, what do we do with it? What do you do with your JavaScript skills? How do you have an impact on the world using JavaScript? In the same way the heart surgeon understands how they have impact on the world with their skills. We have the same opportunity.
Thank you very much for your time, Diana. It was very insightful to listen to you. Thank you very much also for those who participated in the chat with the questions, and we hope to see you soon again.
Thank you.